Hi everyone, I'm Isiki. Today we'll continue with the topic of boundary condition.
At the end of this video, you are going to solve these questions which is related to the boundary condition. So let's go through the questions together. So you have a homogeneous dielectrics fields region X less than 0. So basically you have two regions, okay? So we have two regions. So one is a region the X is less than the 0, okay, and the X is greater than the 0. Okay, so for the X less than 0, it is epsilon R1. This is the medium property. And for the region 2, it is a free space. Okay, so for free space, the epsilon R1 is equals to, epsilon R2. Okay, epsilon R2 is equals to 1 because it's a free space. So for medium 1, okay, so for medium 1, the electric flux density given is 12, negative 10, and 4Z, and 4, and is nanocoulombs, okay, nanocoulombs, okay. And you have to find the D2, okay, the electric flux density, okay, in medium 2, and also the angle, okay, it made with the x-axis. Okay, so this is a theta 2 you have to find. All right, so let's begin with the boundary conditions. Okay, so this is the equation that you must remember for boundary conditions. Okay, and then we have d1n minus d2n equals to rho x. All right, so now what we have here is we have the d1. Okay, so we must break this d1 into normal components and also tangential components. Okay, tangential components. Okay, so by referring to these, okay, we know that this is the x-axis. So whatever components, okay, that parallels to the x-axis would be the normal components. Okay, so we have these normal components. The one normal, okay, normal component will be 12x. Okay, it's a normal components, and the tangential components, okay, would be negative 10 y plus 4z. Okay, they are not nano. Okay, so let's apply the first one. Okay, so since we have the d, so I'm going to convert this one to equations. So E so this one will be equals to d1t over epsilon 1 equals to d2t over epsilon 2. Okay, so this is the first boundary conditions. So we have our we want to get the d2t, right? Okay, so I will write the d2t here. So it's equals to d1t over epsilon 1 multiply with the epsilon 2. Okay, so my d1t is negative 10 nano, okay, and plus 4 nano. So this is my d1t over, okay, so I have epsilon naught. Okay, so epsilon r1 is equals to 2.5. Okay, so I will have 2.5. Okay, and for the epsilon 2, it is epsilon naught, epsilon r1. So the r1 is free space, right? So it's equals to 1. Okay, So I can cancel this one. Okay, then calculate my answer. So it will be negative 4 nano in the y directions plus 1.6 nano in the z directions. So this one will be my d2t. Okay, and it is coulomb per meter square. Okay. Right, so now I'm going to move on to this one. So d1n equals minus d2n is equals to the surface charge density. So in this question, we don't have the surface charge density, so it is equals to 0. Okay, so d2n is equals to the d1n. Okay, so d1n here is 12 nano x. Okay, 12 nano x. So this one will be my d2n. So my d2 will be the combinations of d2t plus d2n. So it will be negative 4 nano y plus 1.6 nano z and plus 12 nano x. So this one will be my d2. Okay, and the unit is coulomb per meter square. Okay, so I have obtained the d2. Now I have to find the angle, right? So this is my d2. Okay, so if I zoom into this triangle, okay, I zoom into this triangle. Okay, we're going to find this the angle. So this is d2. Okay, I need the magnitude of d2, and this is the theta 2, and this is the d2t, and this is the d2n. Okay, so if I want to apply the tangents, okay, tangent theta 2, okay, it will be d2t, okay, which is the magnitude of d2t over the magnitude of d2n. Okay, so let's find the d2t, the magnitude. So the d2t, okay, you can refer here, the d2t is this one. So you can calculate negative 4 nano square and plus 1.6 nano square, and then you square root it. It will be 4.3. Okay, 4.3 nano. Okay, so the value is 4.3 nano. Okay, and for the d2n, okay, it is 12 nano, right? Okay, it's direct. So when you put it into it, so you have the 4.3, okay, over 12. The nano you can just cancel out, right? Okay, so 4.3 over 12. So tangents, okay, so my answer is 0.34 radians. So if you are talking about the degree, it will be 19.71 degree. Okay, so this will be the answer for your theta 2. Okay.